but this one is not long. Quickly, I'm coming back. Design procedure. So participant, who is doing designing? Construction and production. Similar things, construction and production. We need to plan. So as an owner, I want to build my home somewhere outside of Daejeon area. I have a 2 billion Korean won. So I made a contract with the builder, home builder. Then the contractor should have a planning. How long it will take? 6 months or 1 year or 3 months. And for the shed, we have a completed process planning software. And again, equipment vendors, the handle, door handle. Or for the ship, you need to buy steel plate, you need to buy welding, and also we need to buy engine, boiler, radar, propeller, many things. Right? That is all provided by equipment vendors. What is guest engineer? The designing is done by myself. I'm the head of design for the ship. But still, you need the help from other experts, especially coming from vendor companies. The equipment manufacturer, he knows well about propeller. He knows better than myself about the engine. He knows much better than about handle itself. Right? So we call this kind of thing. They are participating in the design project. Somehow, not always, all the time, but sometimes. We call this the guest design. Classification Society, they are checking regulation, safety. So they are also participating in design. Model Beijing, it is testing. Sometimes you will visit the Eureka building there. You see that 10-meter long wood model, and that is used for the tests. And swimming pool. In this area, because we call this a data science town, we have 2 big towing tanks. How big is it? One is 200 meter long, swimming pool, 200 meter for the testing. Oh shit. Second one is 300 meters long. And that is owned by Samsung Heavy Industries, located in this town. So somehow, I don't know whether you have a chance, you may try to visit it. 300 meter swimming pool, indoor swimming pool. They have a test, only testing. We call this a model again, cost analysis important. And then somehow the owner needs to check. Myself, for my home building, sometimes I go visit there to check whether this is going well. But I can't stay all the time. So instead of myself, I may give somebody else who can stay there to check if the building is my home, maybe not. But if I build my own building, 10 floors, it is under the $10 billion, 10 billion won, 100 billion won, something. Right? Then I need to pay another guy to stay there to check. Right? This we call this a ship ownership credit. Combat system for the battleship, acoustic analysis, reliability. Question? Design tool, software tool. So database of previous design is very important. Record. I have a big experience. Hyundai Heavy Industry, they build 80 ships per year. 80 ships per year they build. Then it means 1 year is 52 weeks, right? Then you can guess that every week there is two new ships coming out. 2 new ships. So experience of the company itself is very high, right? They do such business for 30 years, more than 30 years. That is experience and database. Operational experience also can be nowadays more and more sensor network, IoT. Have you heard about IoT? IoT? Yes? No? Yes?
Bird?
IoT?
Bird IoT?
No.
Oh, yes.
No. What is it? Yes. You can do about IoT? Yes? Yes? No. 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 Internet of Things? It is similar to sensor network. You know what is sensor? Sensor. And sensor is network to provide the sensor output to the internet. Because this is thin out. Modeling the ship geometry and perform analysis using computational something, FEM and CFD, that kind of thing is computer simulation. And nowadays, digital twinning, virtual experience. I told you that there is a 200 swimming pool, 300 indoor swimming pool nearby. For the only testing, but how much it cost? Big money, right? For the single test, big money. The model itself is a 10-meter long wood made. Still, it is a 30 times minimized compared to the real ship. Right? So it's small, still small. But for me, it's big, 10 meters. The towing. It's a big money. That's why we need to have a computer simulation instead. If it is correct, and quality of estimation is if high, then we don't need to have a real test. That's why we are doing more and more simulations nowadays. Right. This is a bulk carrier. Here, there's a hatch cover. Hatch cover is located here, so if there are side sliding, and then mineral is here. And side by is a ballast tank, and bottom is also ballast tank. And we call this is a clean ballast tank, and double hull. Double hull means two skin, right? So cargo is only stay inside here. But in old days, there was no such one. 20 years ago, only single hull ship, because cheaper, right? Easy to build. Then what happened? They put mineral here once we go to the Australia to bring coal or ore mineral to the Korea, and then returning back, empty ship goes, right? And then they put ocean water into the tank mixture, and then when they arrive at Australia again, they pumping out the water, and then water near the port is blackout, dirty. That's why somehow, anyway, for the safety, for the pollution, they need to have a clean ballast tank. Only ocean water, or empty. Right? That is the regulation now. Standards. There are many things. Owner's requirement. I want to build my home at wood-made, 2-floor, long ground, kitchen, two toilet, something like that. That is a requirement for me, right? Cargo capacity, speed, endurance. Endurance is how long it travel without refuel. For the electric car nowadays, the endurance is important, right? 400 kilometers, 500 kilometers, 1,000 kilometers without charging. That is endurance. Rules of Classification Society, IMO. This is organization only for regulation, safety standard, health, safety, pollution, environment, and government agency, something like U.S. Coast Guard, atmospheric, and Navy. This is a size of the ships. Container ships, right? Container ships. Can you read? This is a crop? No. Maybe. No. But anyway, the length is 450. And TU, I cannot read this. Anyway, big ships, big container ships. Length. And also, breadth is also increasing. Breadth. Performance requirements. Three main one is cargo, speed, and endurance. These are three main performance requirements coming from the owner. Ship type, conventional, displacement type, monohull, planning hull, catamaran, SWAS, hydrofoil, air cushion vehicle, size, propulsion, diesel, engine, gas turbine, nuclear steam turbine, electric, combined diesel or gas, and propeller, water jet, screw propeller. There are many choices. So, heading. buoyancy of the vessel, how do you get buoyancy from starting from here? Displacement, static, right? So you get a displacement shape, hydrostatic support, Archimedes. And there is a catamaran, we call it a twin hull, and submarine is here. And conventional displacement. This is a very typical ones. Typical ships, normal ships, traditional ships. And Bernoulli, not Archimedes, is hydrodynamic, not hydrostatic. The Fleninger, foil, and two different hydrofoils. And then aerostatic support, air cushion vehicle, and speed range. Speed range up to 100 knots. So it is all different types of ship. It is coming from this one, ship type. Displacement, monohull, planning hull, catamaran. This is a cut area. We already see this. The ramp is working and parking. The big garage here, big parking place on the ship. Ramp. Concept. Have you heard about concept cars? Concept car. What is concept car? Prototype. Prototype.
This one car.
One car, only one car. So it can be planning coming next year or 2 years, 3 years later. Very idealized. We call it concept car. So concept design is similar. Trying to have a new idea, future ships. Feasibility study is a little more earlier stage than concept design. Then you know that the error bound is bigger because of rough design. In terms of cost and weight bound, error bound is. So comparing to the feasibility study, concept design is a little bit more concrete, less than feasibility. All envelope, outer skin, internal subdivision, the walls and floors and ceilings, and dimensions, length, breadth, depth, then we have principal dimension. Perform options, something like block option, the prismatic option, this section, freeboard is come. Freeboard, deck house volume, and existing old hull form is modified by software, computer software. Something like a software name is Aviva Marine, Intergraph. So Navy ship concept design process. I can read, so you can jump up. Similar to design spiral. Critical areas of design integration. Balance is important. Balance between weight and buoyancy. We tested that your body is going down to the floor or floating. We have a question, right? Your body, swimming pool, going down to the bottom or floating? Floating or going down?
Depending on the air.
Depending on the air in your lung. Right? If you high air in your lung, then you will be floating, and empty, you will be going down. Right? So your body is very in the boundary. So weight and buoyancy. This is a balance between your body weight and buoyancy coming from the water. If buoyancy is bigger, it's floating. And weight is bigger, it is going down. Right? That is balance. Stability, capsizing down. Stability. Sail ship, Korean, right? What about the strength? Because of storm, the ship is moving and then break into two parts. It can happen. Right? Power strength is used. The building, storm is coming, small building can be break out. Right? We call this the power strength. Internal volume, this is cargo capacity. For the ship, this one, how many cars can be contained, carried? There's a capacity volume, right? Or parking area. Important for the money coming, revenue. So internal volume is important. Energy balance, electrical power, steam power, compressed air, cooling water. For this building, the design of this building, they should calculate how many steam boiler size, air conditioner size, right? Should calculate how can calculate how many rooms, each room will be occupied by how many person at the summertime, winter time, then calculations, right? Cooling water, power estimation, control is driving control. Archimedes. See, your body weight, air weight, 55 kilogram. Put into the water, submerged. Then water is overflowing. Then your weight is smaller, lower down to 5 kilogram. Then the overflowed water is, the weight of this water should be number. What weight will be this one? 50. There is a balance between buoyancy, weight. Right? This is the same as Archimedes says, measuring the weight of the crown, gold crown. Same. Gold crown is submerged into the water, overflowed water. Same idea. Because human body is complicated shape. Right? Yeah. That's why. So now for the ship, the displacement, this is same as the buoyancy. Should be same as total weight. Your body again. If you have a long full of air, your body is floating a little bit. Tip of your head is above the water, a little bit. Then the other remaining part is in the water. Empty lung, your body is going down slowly. There is a balance between buoyancy and weight. So for the ship, the total weight of the ship, if you bring up into the air, it happens for the sail ships. for the Korean guys, several ship, they want to lifting of the whole ship. But myself need to calculate what will be the weight. My calculation was 10,000 ton. Then how can we use, which crane should be used? Eh? That crane should be bigger than 10,000 ton. Eh? Otherwise, we cannot bring up this ship above the water. That is total weight, 10,000 ton from Seoul. Now, in the water, the balance is the balance stable. Then we know that VRC from the water is same as the total weight of the ship. For the Seoul is a 10,000 ton of weight is supported by water. Yes. This videos goes of time. Next time I need to bring a water tank, small water tank to show you the VRC and weight. I forgot to bring this. Question. And we may have a 5-minute break.